Okay, in this video we're going to talk about absolute value equations and start some discussion on inequalities. We'll have several other videos on inequalities as well. Now, absolute value, I think we've talked about this in one of our review videos, but we have absolute value of x. And some people like to think of this as just it makes everything positive. And while that's okay to think that way in a computational standpoint, it's really not what absolute value of x is. Absolute value of x is the distance x is from 0 on a number line. And so let's look at an absolute value equation. And for instance, the absolute value equation we can look at is 3x plus 2 absolute value equals 7. So what we want to think about this is if we think about a number line here, and we think about here this being 0, and then I'm going to draw in a distance of 7. And I'm just going to say that that distance is 4 squares. So this distance of this line is 7. And of course we know that this would be then the number 7 here. But then if we're talking about how many numbers have a distance of 7 from 0, there's 2. Of course there's positive 7, but then if we're also saying what's another number that has a distance of 7 from 0, we have negative 7 as well. So when we solve absolute value equations, we're actually going to wind up with two equations that we're going to solve. We'll wind up with 3x plus 2 equals 7, because that's one possibility, or the other possibility, because the distance being 7, is that 3x plus 2 equals negative 7. And then at this point it's just solving two equations, and then getting both of them here. So we just have 3x subtracting 2 from both sides is equal to 5. And I'll just go ahead and solve them both at the same time, and so we'd have 3x is equal to negative 9. Divide both sides by 3 and we get x is equal to 5/3, or x is equal to negative 3. And we'll do one more example and then we'll move on to inequalities, but they're pretty straightforward. I'll do one that's a little bit more challenging. Let's look at x squared plus 6x is equal to 3x plus 18. Now we're going to still do the same thing here, it's just my distance now is 3x plus 18 as opposed to just a number. So we're going to still wind up with two equations. So we have x squared plus 6x is equal to positive 3x plus 18, or you'd wind up with x squared plus 6x equaling negative, now I'm going to put a parenthesis because it's a negative of the entire right hand side, 3x plus 18. And so what we have here, I'll solve one and then solve the other side here. We have a quadratic equation, so we need to move everything to one side. So I'd have x squared, subtracting 3x from both sides would get me plus 3x, and then minus 18 is equal to 0. And if we look at this just for a few minutes or seconds, we can see that this factors, and this would factor to x minus 3, x plus 6 equals 0, and we've done these now several times. This would give me answers of 3 or negative 6. So let's go over and look at our other one. So this would be x squared plus 6x. Then I'm going to distribute that negative sign. So this is equal to negative 3x minus 18. And then again it's quadratic, so I'll move everything to one side. So I have x squared plus 9x minus 18, I'm sorry, not minus, plus 18 is equal to 0. And this factors as well. This factors to x plus 6, or x plus 3 equals 0. And then we get x equals negative 6, or x equals negative 3. Then we just combine all of the things down and write our solution. So our solution would be negative 6, negative 3, or positive 3. Now you could check each one of these answers and verify that it solves that equation. I'm not going to do that. Alright, so now we're going to move into inequalities. So let's talk about linear inequalities. And we're going to first talk about some properties of inequalities that have to be true in order for it. And this is some of these properties, especially the first one, is going to matter when we're actually solving inequalities. Okay, so the transitive property has to hold true for inequalities. And what do we mean by the transitive property? Well, if A is less than B and B is less than C, then A is less than C. And that's just saying, for instance, if you have numbers, for instance, negative 2 is less than 3, and 3 is less than 5, then negative 2 is less than 5. And what we're going to use this for is when we're trying to combine inequalities together, we're going to test to see if the transitive property holds, and that's going to tell us whether we can combine the inequalities together or not. Okay, so there are some other properties here for inequalities, and the first one here is adding inequalities, and I'll be honest, we probably won't use this one too much, but it is something that's important to talk about. So this would be if you have two inequalities, for instance, A being less than B and C being less than D. And you can add these two inequalities together just like you would add two equations together, and what you'd wind up with is that A plus C is less than B plus D. Pretty straightforward, adding the left-hand sides and the right-hand sides together. Now, one thing I should point out here, in all of these rules we're using the less than, but these properties hold true for less than or equal, greater than or equal. We just write them down once with the less than sign, as opposed to writing them down multiple times. So the third one here is adding a constant. Now this one and the fourth one we're going to use quite a bit. So instead of adding inequalities together, adding a constant, we're going to start with an inequality and a constant C. And what we're saying is that if we add that same constant to both sides of the inequality, that the inequality still remains true. If you have A less than B, then you would have A plus C being less than B plus C. Very similar to an equation. If you add something to both sides of an equation, it doesn't change. Now, I'm not going to write one down for subtraction. The reason I'm not going to write one down for subtraction is I really don't need to, because subtraction is the same thing as adding. And you might say, well, how is it the same thing? They're different operations. Well, remember, subtraction is really just the same thing as adding a negative number. So we automatically get subtraction if we're adding a constant to both sides, because there was no restriction on the constant. It didn't say the constant had to be a positive number. It could have been a negative number. So if adding a negative number is the same thing as subtraction, I get the subtraction one automatically. And it's the same thing for multiplication and division. We'll only do the multiplying one because division is just multiplying by a reciprocal. So multiplying by a constant. Now there's actually two cases here that we have to, and they are distinct, and we have to be a little bit careful with them. The first case is that if C is a positive constant and we have A less than B. Well, the result then is that you can do A times C, and that would be less than B times C. So multiplying the same thing on both sides of the inequality doesn't do anything. Now, you can kind of guess if we're talking about C being greater than 0, we're going to want to know what happens if it's less than 0. And we still have the same inequality, A less than B. Now the difference here is we still can multiply both sides by it, so I'd have A times C and then a B times C. And some of you might already know this. What happens to the inequality sign is it actually changes directions. So I'd be A times C greater than B times C. So multiplying by a negative number changes the direction of the inequality. And I'm going to star that because that's an important thing to remember. Alright, so let's look at some examples here of solving inequalities, and then we'll look at ways of writing the answers. We'll look at putting them in inequality notation, a graph of the solution, and then also interval notation. Alright, so let's look at a fairly easy example to start with. So we're going to start with 10x being less than negative 40. And now to solve this one here, all we have to do is divide both sides by 10. Now, we don't typically write it here, but I'm going to emphasize when I'm dividing by 10, I'm dividing by a positive number, so the inequality direction does not change, and you'd have x less than negative 4. So this would be my inequality notation. But then, of course, I could graph this as well. Let's see what happens here. If I graph this, let's go ahead and get a number line here. I thought that was going to be great. I might as well just draw them here as opposed to using the tool to draw them. So, number line. And then I'm not going to worry too much about scale, but I'm going to put here negative 4. Now, since I'm less than, not less than or equal, we would put an open circle at negative 4, and then we're less than. So we would go to the left, shading that, and then put an arrow indicating we go on forever and to the left. Now we could also write this as an interval. And the interval, well, I go all the way to the left, which means I go all the way down to negative infinity. So the interval notation would be negative infinity, and remember, infinities always get a parenthesis, comma, negative 4, and the negative 4 would have a parenthesis because it's less than and not less than or equal. So this would be graph, and this would be interval notation. Alright, so let's look at one more here. Let's look at negative 6x is less than or equal to 18. We'll look at a couple more examples, but this is kind of the last, what I would consider basic example here. And so let's go ahead and do this. Well, this one, of course, I would divide both sides by negative 6. Now I'm dividing by negative 6, so that means I need to flip the direction of the inequality. So I'd have x flipping the direction would be greater than or equal to negative 3. Now, we could graph this one as well. And if we graph this one, just have a number line here. And I'll put this as negative 3. Now, it's greater than or equal, so I put a solid dot there. And then I would shade to the right since it's greater than or equal. So that'd be a graph of my solution. One more we could look at here is the interval notation. The interval notation would of course be a square bracket because we get to include that point negative 3, and we go up to infinity, which would have a parenthesis. Okay, a couple more examples here and then we'll wrap this video up. So those first couple examples are pretty straightforward. This next example I don't think is really difficult. It just adds in a couple additional steps here to solving this. So we have 4 times x plus 1 less than 2 plus 8x. Now we're going to solve this and really kind of approach these as solving any type of equation. The only difference is of course that you have to keep track if you multiply or divide by a negative number. So first off, if I was solving this like an equation, I would distribute. So I'd get 4x plus 4 less than 2 plus 8x. And then I'd move the x's all to one side. So I might just like this as 4 less than 2 plus 4x, because I'd do 8x minus 4x. And then I'd move the 2 to the other side, so I'd get 2 is less than 4x, divide both sides by 4, and you would have 1/2 is less than x, or if you wanted to, you could write this as x is greater than 1/2. Now we could graph this one again. I'm not going to bother graphing this one, but I will write the interval notation. Since it's x is greater than 1/2, this would be 1/2, to infinity. Alright, so let's look at one more example, and then to wrap up the video here, we're going to, actually we might do two more examples, but to wrap up the video we're going to talk about some mistakes people make with writing these down here. Alright, so let's look at this example here, because sometimes we have more than one inequality. 0 less than or equal to x plus 5 over 2, which is less than 4. Now this has got two inequalities here. Now this is where I'll already point out you have to be careful. This one is okay. The reason it's okay is the transitive property holds. And I'm going to write this off to the side here. We have 0 is less than x plus 5 over 2. And we also have that x plus 5 over 2 is less than 4. But the transitive property would imply then that this is 0 is less than 4, which is absolutely true. So I'm okay writing it as one long inequality like this. Now what wouldn't be okay is if, for instance, I had this being a negative 1 over on this side, because then you'd be saying 0 is less than negative 1, which is not true. So if you see a problem in the book like this, they're going to write the problem correctly, but when we start looking at some other ones, like when we start looking at absolute value inequalities, we're going to have to be a little bit more careful with that. Alright, so let's go ahead and solve this. Now, we can still solve this just like any equation, and what I'm going to do is, since I've got a 2, I'm going to clear that fraction out, so we multiply everything by 2. So I have 2 times 0 less than or equal to x plus 5 over 2 times 2 less than 4 times 2. So, of course, 2 times 0 is still 0, less than or equal to x plus 5, which is less than 8. And then to wrap this up, we'd just subtract 5 from both sides, and we'd wind up with negative 5 less than or equal to x less than 3. And so this would be my inequality notation. Now we could graph this as well. And if we graph this one, we would have negative 5, and I'm not worrying about scale here, so I'm just going to put negative 5 here, and that's a solid dot, and then I'll put 3 over here, and that's an open dot, and then we'd shade everything in between. And that would be the graph of our solution. And then finally, if we wanted to write this in interval notation, we could write this as square bracket negative 5 comma 3 parenthesis. Okay. So as I said, we have to be careful with this, and when we start the next video on inequalities, we'll see that more about having to be careful with how we write these. Okay?